Okay, let's begin. Good afternoon, good morning, good afternoon, good evening from wherever you are joining from, and welcome to the Data Driven Community Virtual Meeting. A few words about the Data Driven Community. We have two different branches, Future Data Driven Summit and Cloud Data Driven User Group. For more information, please click the community website. I'll add the link to the chat in a few minutes. Scroll down the page a little bit to see the upcoming events. On the left side of the page, you can notice the information about the Future Data Driven Summit 2025. This is an annual joint conference we are leading and running with multiple data platform user group partners. The second branch of the activity we run are the weekly meetings of the Cloud Data Driven User Group, like we are having today. You are more than welcome to contact any of the community board members. My name is Deepthi Goguri. I'm a database administrator and a Microsoft Data Platform MVP. I'm the third co-admin of the Data Driven Community, and I'll be hosting this meeting today. You are more than welcome to contact any of our community board members. Jean Joseph is the founder and the secondary co-administrator. Ronan is the primary co-admin. Together, we are here to help and serve the data platform community. During the meeting today, please feel free to use the chat for any questions and discussions as well. You are more than welcome to use the reactions. It doesn't interfere with the course of the meeting. If you hear something you like or love or want to clap hands, then feel free to do so. I'm honored to introduce our guest speaker today, Edward Pollack. Edward is a data architect, Microsoft Data Platform MVP, author, speaker, and also a event organizer. Edward, can you please share your screen and add a few more words about yourself?
Thank you very much for having me today. I do appreciate being here. This is a great group that meets so often and provides so much content to the community. It's pretty amazing, actually. So that's my summary of Cloud Data Driven. Is the amount of content provided is astounding, and so I do truly love that. So thank you to everyone for being here today. This presentation today is all about query optimization, and I say fundamentals, I do mean that. This is not a highly advanced session, though honestly, even if you have more experience, you may appreciate some of the reminders of how things work with data and the real world and how all this works. So this is really meant to be talking about uptime and improving performance, and we're going to go through a lot of things that are really, really important that I take none of this for granted because everywhere I've been in my life, there's been problems with this stuff. So we're going to dive right on in. So first up, me. This is me. I'm a Microsoft Data Platform MVP. I've published some books. I write regularly on Simple Talk. I have articles elsewhere. I organize bunch of events, SQL Saturdays, our user group up here. I've spoken at many events. I do a lot. It's fun. I enjoy it. If you ever see me out there, feel free to say hi. I will be at events all over the place, I'm sure, virtual and in person. So feel free to enjoy more of my content if you want. I will send all of this out afterwards, the slides, the demos, everything. So do not feel obligated to copy frantically until smoke is rising from your keyboard. I will send it all out. I'll post it on Meetup immediately afterwards, and I'll also send it over to the organizers in case they have anywhere special they want to put it. With that, off we go. So this is going to be a straightforward presentation. Why does this matter? Why does query tuning still matter? Why do we care? And what are the most common problems and solutions that we run into out there and the best practices and guidelines? And these are important things. There's a million edge cases in the world. We can easily spend months, years, forever talking about edge cases, the things that happen 0.5% of a time, or 1/10% of a time, or once in a great while, but we're not going to do that because most people don't need that. When edge cases happen, you identify them as edge cases and you deal with them and you treat them just as that. If you begin treating edge cases like the thing that always happens, everyone gets mixed up is down, and nothing makes sense. So it's very important to differentiate between best practices and guidelines that should apply most of the time, and then the edge cases that we deal with outside of that. So that's important. And then what's in the future? What should we look forward to as things change and we move forward? This is the key part. Everyone asks, why are we still doing this? Can't AI do it? Can't machine learning do it? Can't auto-tuning do it? Can't I ask ChatGPT? Why not? Can we automate this problem away? And the answer is sort of. It can help you. You can give ChatGPT or Copilot a query and ask for help, and it might be able to help you. And that can save some time, and that's great as a tool. But the big challenge we have as time gets on, no matter what we do, are all these things. Reality, basically. In an ideal universe, when you're in the physics class in 7th grade talking about ideal gases and vacuums and things, it all works beautifully. But then reality is never like that. Reality is you have business logic, you have legacy code, you have a complicated app, you have developers that come and go, people get fired, they leave, you have just complex queries that are hard to understand. You have domain knowledge, the fact that some people know things that other people don't, and certainly ChatGPT is not going to have that domain knowledge. You could have different standards over time that develop and change. So there's just so many possible ways like these and others that I didn't squeeze in here for life to be a little different than that. And the more nuanced the situation gets, the more advanced the situation gets, the more domain knowledge that is required to solve a problem, the less able a tool is to do it for you. It can still help, and help is great, but to make the final correct decision needs a little more than that. And so whether you have help or not, you're ultimately going to have to make decisions that are very important that can't be done in a vacuum outside of your purview. And honestly, if a tool could do it all for you, you wouldn't have a job. And so there's still a lot of value out there for not administration as much, but engineering and optimization. Optimization is a key skill. It really is. It's important. We want that. And if you're good at making things fast and solving those kinds of problems, you'll be valuable, no matter how you get and arrive at those solutions. So the typical workflow is hard because we don't like it. As tech people, we want facts, we want details, we want information, and we may or may not have that. And by the way, I'm going to have the chat open here. If anyone happens to have any questions, you are welcome to put questions in the chat. I'll peek over every so often and try to answer them if I can, or push them off till later when we have more time. So, the typical workflow stinks, right? Basically, someone's going to go to you somehow and say it's slow, and they're probably not going to tell you a whole lot of information as to why it's slow, and they're going to say make it fast. And it may not even be the database, but people will assume it is. So what do you have to do? You've got to basically prove it's the database or not the database, and then find a solution to the problem if it is. So once you know it's a data issue, query issue, you've got to solve it somehow. But you're given very little to start with, and that's a huge problem we all deal with. This is not easily solvable, but this is normal. It's very rare that you'll have good support people behind you who will hand you everything you need in a silver platter and say, here's the query. We know it's slow. Make it fast. If you have that, you're lucky. That's great, but that's hard to get. So what do we do? Well, the basic workflow is important. We've got to start with a workflow to get to success. And I'm going to spend a little bit of time on this before we dive into best practices and all that. First of all, can you reproduce a problem? This is important. If you cannot observe it or reproduce it, I got nothing. If you can reproduce it, great. That's huge. You can now go in there and have whoever made the slow thing happen do it again, and you can do whatever you got to do, extended events, profiler, dynamic management views, whatever you need. We'll have some example queries. Actually, I'll have tons of example queries. I love live demo. It's exciting. It's fun. I will have lots of queries to show you, and I'll send it all out afterwards. So you don't have to go copying it all down. If you can reproduce it, great. If you cannot reproduce it, then you need to go find logs or just push back and say like, hey, you gave me nothing. I need more information. Go. Don't be afraid to do that. Depending where the requests come from, you may or may not have an easy job solving it. The key you need really ultimately is the query text. Wherever this query is coming from, whether it's coming from an analytics solution, from AI, machine learning, coming from an application, it's probably a transactional application. It's usually where a lot of this stuff comes from, but you need to see the query. That involves getting the query text. Once you have that, maybe it'll be easy, maybe it won't. You'll probably want some metrics as well. CPU, I/O, memory, speed. What's that duration? Is the query 5 seconds, 5 minutes, 5 days? That's important. And once you have resource metrics and SQL metrics, you can then begin to dive in and solve the problem. But without this stuff here, you can't even begin to solve the problem. Some people get ahead of themselves. They dive into the empty pool head first thinking I can solve this really fast, and they waste time. And so you really have to go through this list quickly and make sure you have what you need to solve a hard problem. And this may not take long to get, but it's good as a checklist just to know I have everything I need to solve the problem. And once you're at that point, you have all the things you need, now we can talk, and life gets a little bit better. Number one, though, before we even dive into the SQL text and look at the query and try to understand it, is what is the purpose of this query? This is really important, and a lot of people dive in clinically and never ask this question. The number one thing we have to do when talking about a query is identify what the heck is it for. And yes, this is a strange clip art that I threw a database in. It's what I do. MS Paint's fun. What is the purpose of a query? Why does it exist? Where is it coming from? What is its source? Is it an application with a user clicking and waiting? Is it Power BI? Is it a report that gets run overnight that can take a while? That's important because it tells you how time sensitive the query is. Is it executed once a day, 100 times an hour, 1,000,000 times an hour? That's very important. How often? If it's a once a day thing, you should treat it very differently than if it's 1,000 times a minute. Then it's very different. How much you're willing to do for it will depend on how often it runs. Is it breaking the server or not? What is the size and shape of the output? This is an important question too. Is this query returning a reasonable amount of data? For example, if a user's in an application and they have a grid of orders from the place they buy stuff from, that grid shows 20 at a time, and you can click through it. Is this query returning a number of rows that makes sense? Or is there a missing filter and it's returning 1,000,000,000 rows? This happens all the time in applications. An app will consume 20 million rows from the database and throw away almost all of it and give the user 100. But that's inefficient. Pulling 20 million rows from a database will take a long time. It'll take time to read it, time to push it over to the application, time to consume before you throw it all away. So make sure that the size and shape of that output makes sense. Do you need all the columns, or is it select star? And is it too many rows? Because very often if it's user facing, you don't need 1,000,000 of something. And if you do, maybe pre-crunch that data somehow so you don't have to go sending it places, because a lot of app servers don't want to try to choke on hundreds of millions of rows or whatever. And then who's dealing with this? What's dealing with it? Is it a person? Is it a thing? Is it an app? Is it a report? Where is this data going? Is it for ETL? Is it for ELT? Is it for a data lake, a data warehouse, a person? What is it for? Knowing who's getting it is important because it really helps you understand fully the time sensitivity and how fast should this thing be. And if no one tells you how fast it should be, you should ask. Is 1 second acceptable? Is 5 seconds acceptable? Is a minute okay? Because if you don't even know that, then you don't really know how far to go with optimization. Is it breaking a server? Is it doing so much I/O or taking so long that it blocks everything and creates server problems? This is all important to know. We probably don't want to do those things, right? But in an analytic environment, maybe it's okay. And of course, ask, is this thing used? The number of times in my life I've been handed a query that was breaking stuff, and then eventually I found out that either it wasn't used for anything real, or we can get rid of it because no one really needs it, is a non-trivial number of times. So do ask people the question, like, what is it used for and is it needed? What is it needed for? Can we change it a little? Is the output changeable or is it required to be exactly as? These are all questions to ask before you even start optimizing. If you don't have these answers, the more you're missing, the harder this process gets. And another important question to ask is, when do we stop? This is really important. This is why I asked the question before, how fast should it be? How fast should the query be? Should it be 1 second, 5 seconds, 10 seconds, and how fast is good enough? Because there's always the law of diminishing returns. I can take a query that takes 1 minute to run and get it down to 1 second, and the effort isn't too high because I saw an obvious problem. Great, awesome, I'm a hero. But then what if I spend the next week going from 1 second down to 0.4 seconds? Was that really worth it? Did I really help people? Did they really notice? Was my 1 week of time well spent? And the answer is maybe, if it runs a lot, but very oftentimes no. And so be willing to know when to stop. How fast should it be before you say, I've succeeded, I'm done, everyone's happy, if we've got to revisit it again in the future, no problem. And look for alternative solutions too. It may not be a query problem. Many problems of its slow nature may simply be solved by something else. Like there's an application problem or a query problem, or like an I/O issue, a server issue. Maybe the server is out of resources. So whatever the thing is, make sure that there is an alternative and better solution than trying to tweak something that may already be pretty good. And once performance is good, move on. So just remember that optimal means fast enough. Just the query optimizer tries to find the best execution plan for your queries. Optimal means fast enough, not as humanly fast as possible, because going as fast as humanly possible may require a lot, especially if it's a big query or a big stored proc or something like that. I don't see any questions in the chat. If you happen to have any questions, feel free to throw them in there, and I will be happy to answer them, or try to, of course. There are many tools available. There are third-party tools out there that you can purchase that will help you, and there are things you can do to get information, from things like Query Store and Extended Events and Profiler, which are kind of external-ish tools or part of SQL Server, to queries you can run. And what you use will depend on what's available to you and your experience level. I'm not going to demo everything. This is not a session on Query Store or Extended Events or Profiler, though you can definitely find those things out there. But I'm going to show a variety of queries you can run from within SQL Server to give you information. You can use these if you want. If you have alternative solutions, great. I will send all this out later so you have it. So we'll get started here. I have no count on to avoid extra noise. And, you know, the simplest thing you can look at here is an execution plan. And viewing that is straightforward. I put an actual execution plan. I can look at the estimate as well, but I like actual and possible. It gives me a little more information. I run a query. I get my results. I go take a peek, and I see an execution plan. And this execution plan tells me right to left how this query ran. There's lots of detail. If I hover over things, there's more information you'll probably ever need. But you might, so it's there for you. Scan means I read the whole table. Seek means I read part of the table through an index. We'll talk a bit more about that later. But this is a tool, though. This tool is very easily available. You can turn it on or off at will. You can run queries and do it and get what you need. Another tool we can look at that's commonly used is statistics.io. You can't solve every single problem in the world through I/O, but I/O helps to tell you how much tables are being read. You turn it on just like this, and then I run my same query, and I can look over here under messages, the output over here, and I can see what the reads were in my tables. Very straightforward. I can see the suppliers table, 20 logical reads, stock items, 16. And logical reads are numbers of pages read. So in SQL Server, a page is 8 kilobytes. So this is 20 times 8 kilobytes, and this will be 16 times 8 kilobytes. That's all. It's just a measure. So in general, smaller numbers are better, bigger numbers are worse. If a table is small and you're seeing a very large number of reads, that means something is very inefficient somewhere. If you're reading the whole table, but you expect to not read the whole table, again, something might be wrong. It's worth thinking about. This is a little useful as well, though honestly I prefer the actual user duration. So I'm in an application and I run something and I want to know how long it takes. The user tells me. Or I hit F5 and I test a query 10 times and I measure the time, you know, kind of unofficially by hand. Statistics time works as well. You can turn this on, and when I do, I will suddenly get some additional information in my output. You know, elapsed time for parse, query, and execution time. This is useful. You can look at it. Just keep in mind, these times are variable. They're impacted by whatever else is going on your computer, your server, whatever. And so if somebody else runs something at the exact same time, this might go from 8 milliseconds to 12. That doesn't mean that it increased to 50% and is much, much worse than before. And so it's important that when you're measuring the duration of something, that you measure it enough times that you understand what's going on. There's a question here, why is an application table not here? Oh, good question. That is a great question. You noticed that. Very well done. In the execution plan, why was the application table not referenced? And why under I/O was it not referenced? And the answer is to left join. That was never used in the query. I put that there intentionally, and you caught it, Manish, so thank you. Good catch. I intentionally put a table here that was left joined and never used, and the optimizer was smart enough to say, you know what, it's a left join, you're not using any data from it, we'll skip it. Excellent question. So statistics time is useful, as is measuring duration. Just be aware of the fact that you're looking for meaningful change. If it changes by 1%, that may not be meaningful. If it changes by 100%, 200%, 50%, that's meaningful. When the query goes from 10 minutes to 5 seconds, that's wildly good. When it goes from 10 minutes to 9.8 minutes, I'm not sure I'm making a big impact. Here's another one. There's many ways to get CPU. There's third-party tools and performance monitors. I do it this way using a query here that gets me the SQL Server CPU. There's many ways to do this. So pick your poison. There's so many ways to do this. Obviously, my local server is mostly idle. This tells me that the SQL Server is using next to nothing, and the server is using 3%, and 97% is idle. Many ways to do this. Feel free to use whatever is convenient for you. There's no right or wrong way to get CPU or memory or I/O or network bandwidth or those kinds of things. So again, whatever way is best for you. I'm just showing one random way to do it here for fun, but use whatever way is best for you. Performance counters. Windows is full of these. If you're on Windows, you have lots of these. If you're not on Windows, you may not have this sort of thing available, or maybe different. If you're running a SQL Server on Linux, things are a little different. Anything that is DMOS might be a little different. And so this view provides performance counters in Windows and the SQL Server. These are all SQL specific. And I'm getting a whole bunch of stuff here. Again, the use of these will depend on what you're doing and how much you need them. But different ones are useful. Page splits could be useful. Very common ones that are used are things like page life expectancy. Extremely useful. This will tell you, right now overall how long is a page staying in memory, which is based on your workload and how long your server's been up for. Connection memory, how many users are connected right now, how much free memory is there, and so on and so forth. So lots and lots of metrics. There's many more, by the way. This is only some. And so you can kind of dig in and figure out which ones you need and don't need, but they can all potentially be useful or not. You may use none of these in your work and be perfectly happy. So I'm just showing options. Options are always available. Blocked processes are not very hard to get. You can just do a count from DM exec requests for where the blocking session ID is not 0, not null. Right now I have none. No surprise here. If I created some blocking, the number would be greater than 0. No biggie. Okay. Another one you can check for fun, which you may or may not need, is median plan age. This tells you in cache how long have plans been in cache, execution plans. And if the number is very small, then that means either you have nothing or it's a problem. The bigger it is, the better. In this case, my server is very quiet. There's very little in cache. This is not very exciting. And so again, these are relative numbers. And in general, if you think things are slow, this might matter. And by this is just getting median. Percentile disk or 0.5 is median. That's all. Nothing fancy here. Probably one of the more useful things you can do, if there's a problem right now running at the moment, something is slow right now, at this moment, somebody says, hey, we're running a thing right now, it's still running, it's slow, help, is go out, and I get a lot of detail here. Do you need this much detail? I don't know. Maybe. You can trim this query if you want. I get a top 100 of a whole bunch of stuff from exec sessions and requests with connections as well for fun, just to get like the IP address. And I order by CPU descending. So basically, give me all the requests descending by CPU. You can omit the ones with your current session if you want to, but you may not want to. And I can see here I have my one current session here, and this gives me a lot of information. I can see CPU, logical reads, the statement text is right here. It's the query I'm running right now. The login, the host, I know who to blame if there's a problem. Great, blame is cool. I mean responsibility, not blame, just kidding. The local net address tells me it's the local machine. Program name, if it's not the default port, I'll get that, so on and so forth. So this is a mountain of information. If a query is running right now, at this moment, you could run this and find out what the top queries are, and you can adjust this. You can order by logical reads descending, or you could do a select star, though I do caution you, it could return a lot, which you may or may not want. The statement text can be big. You might want to omit it if things are getting big and crazy. You can just do a count star. A count star from this query would simply return how many queries are out there right now, how many requests are out there. If that number is giant, like 1,000, I'm worried because a lot of things are pending and running, and that may not be normal for your server. Maybe it is, but it probably isn't. If the number is more than usual, what you expect, that could be too much. So again, sorting by whatever you think the problem is makes sense. It'll probably be CPU, but you never know. Could be writes, could be elapsed time, right? Maybe it's the elapsed minutes or of the query, which isn't there as well. Query has been running for 20 minutes. Why is it running for 20 minutes? Let's look at it. So The order by is a little, you can decide what you feel like doing here, but it's helpful. So you can go back and, I could run queries and look through all this stuff, and we can see what we're doing. I don't really need this here anymore. We've already played with it. So just an example of some internal tools that you can use that don't cost any money, that are right out of the box in SQL Server, that will help you solve problems. You don't have to use them, and you can use third-party tools if you have them, or Query Store or other solutions. Lots of sessions on them, and if you have a third-party vendor tool that you're not fully confident with, feel free to look up documentation and videos, and I promise there's so much out there, way more than the hour that we have here to talk about it. Now, for the rest of the session, we're going to talk about common challenges and solutions. This is the meat, really, of it, is what are we looking at doing here? What do we want to solve? What are the common things that I see out there when I look at these problems? Let's dive right on in. The simplest problem, the one you should check first before anything else, is just check indexing. This is important. The purpose of indexes is to make sure that you have efficient table access when queries need to get data. If your table has 10 million rows, reading 10 million rows might be kind of slow. So you have indexes to help speed that up. The key to indexing, and you should always check and make sure, like, if a query is slow, do I have an index? Do I need an index? And if the answer is we're good, we have what we need, move on. If we don't, investigate. The keys to indexing, though, are don't index every single query. If you do that, you're going to hurt yourself over time, because every index you add makes your writes a little bit slower. If I insert a row, delete a row, update rows, then I'm going to have to update all the indexes that reference them. And so if you have 50 indexes in a table and I delete a row, well, I've got to now update 50 indexes and remove that row from all those indexes, and that's not pretty. So it could take a while. It also takes up storage as well, all those indexes. So you don't want to over-index a table. In general, indexes should cover the most common queries and the most expensive queries. Don't index every query. If you do, you'll end up with a table full of indexes and you'll be sad. And don't blindly add in all the things that Microsoft recommends. If you run queries all over the place, you will see the green text in Management Studio. Do I have one here? I don't have one here. That's too bad. Sometimes right here under the execution plan, you might see a recommended index that SQL Server says you might want to add. You don't have to add it. That only appears there because it will make the query better. But how much better will it make it? It may or may not be the right choice. So you should always review and make sure, is there already an index? Is there already a good enough index? Don't just add include columns for fun. If you have a specific column that you filter by a lot, start with an index on that. Don't add include columns and all the extra columns that you need yet. You may not need them. You might, but you also might not. Start with the less aggressive one and go from there. Test first with that, and it might be good enough. If a simple index on one column brings the query from 5 minutes to 5 seconds, that might be good enough. If that query runs 1,000 times a minute and it's really, really important, then yeah, maybe further columns would help. Maybe. But that's a judgment decision based on how far you need to optimize, not something we do blindly. And check usage periodically. There's whole sessions out there. I've done sessions on it. Feel free to look them up on index usage and missing indexes and how to understand which things to be add or remove, so on and so forth. So just remember that indexes improve read speeds, but they will slow down your write speed and storage. So just remember that. It's a trade-off. So just number one thing, really quickly, just verify, is table access make sense? Are you scanning tables you should be scanning? Are you seeking tables you should be seeking? Does it all make sense? Which leads me to what are scans, seeks, and lookups. Quick review of that. When you perform a scan on a transactional table, not column store, you'll be reading an entire table or index, the whole thing. This might be what you want. If a table is big and you're reading the whole table and you want to read the whole table, this may make sense. Or if you're reading most of a table, if a table is a lookup table with 20 rows and you want to read all 18 of those rows or 20 of those rows, then a scan makes perfect sense. It really does. There's no reason to do a seek. It'll take longer. Just scan the table and be done, especially if it's small. If the whole table fits on a page or two, it may just scan it, and that's fine. So scans aren't all bad if getting all the data out of an object makes sense. A seek is a narrow search. So we have lots of rows, and I want a small number of them. When that happens, I want to seek. That's for filters when I'm filtering down a data set from big to small. I expect a seek, and if I don't see some sort of seek, clustered index seek or non-clustered index seek or whatever, then I'd be wondering why. If I'm returning 10 rows to the user and I read a billion rows to get it, I'm going to wonder why. Like, why did I have to go through that much work and read everything to get 10 rows? And last but not least, lookups are when you have an index and you seek it, but then you have to go back for some columns that were not in the index. And this might be okay. In fact, most of the time, this is perfectly fine. If a query is run often enough and aggressively enough, then you may want that extra columns added to this as a include column set to make that lookup go away and replace it with a seek, a pure seek with no lookup. And that's fine. But it's a judgment call based on how fast you want the thing to run. You don't always need to put the include columns in there, and similarly, lookups aren't always bad. Important caveats. It's easy to get into the habit of thinking that all the scans are bad, all the lookups are funky. You don't want those kinds of things, but they're fine. There's no problem. Number one thing to ask is when you're filtering and working with data is what are the data types? Everything has data type, obviously. Every column in SQL Server has a data type. You can look at it in the definition. If you're not sure what it is, you can look and check and find out. Make sure that the data type that you have for the column definition matches whatever's comparing against it. That's important. You know, whether you're in a query coming out of an app or a stored procedure or a function, whatever, make sure that your data types all match. If data types don't match, and that can happen if you change the definition of a column, they don't match anymore. If they're different, SQL Server will try to convert it for you. If they're similar, like an int and a small int, it might be fine. It might work out perfectly fine and life will go on. Assuming that your value doesn't exceed the size of the small int, in which case you might get in trouble. But it'll probably be okay, performance-wise. If the data types are wildly different, like an integer and a string, well, you compare those, you might get an error message because it can't always compare, you know, the letter T or a name to an integer. And so be careful. You know, if the precision is different on this side of a filter and this side, you may accidentally round some data as part of the conversion, and you may not want that, right? If you're working with money, you have an integer on this side, you may accidentally round away all the cents, and it may not sound like a big deal until someone gets an invoice, or you're summing up a whole bunch of orders, and suddenly the numbers get big. So be cautious. This is a big deal. If you filter on a column and your data type is wrong, you may accidentally unneededly cause an implicit conversion. I have a little speech bubble there, and we can show that right now. So what does that look like? What's an implicit conversion? Sounds weird. If I run a query, this is very simple. This looks natural, right? I'm running a query on the customer purchase order number, and I'm looking for this one, right? At first glance, this is perfectly normal. Looks great. I love it. You love it. We all love it. And I run it, and it takes a few seconds, a little more than I would have expected. I check here, and I did a whole ton of reads. Strange. I check here, and I see a clustered index scan. But I filtered on a column. What's going on? What's going on? Oh, I just need an index. All right. Oops. Let me add the index. All right. Whew. I've got an index in the column. I researched it. It made sense. I put it on because people search for this all the damn time. And now I have an index. Phew. I'm going to run my query again and be successful. And it is faster. But I check here, and the reads are still really high. And I'm still getting an index scan. So now I have to ask myself, all right, it performed better, but it's still not good. What happened? Why wasn't it a seek? I put it, there's the index, it's right there. I added it just now for you to watch. I did it right in front of you. So what happened? Well, it turns out if I hover over the column, Management Studio tells me, hey, that purchase order number is actually an nvarchar 20. It's a string. So this is a string, and I put an int here, or whatever, some numeric. Well, the solution is actually easy. I simply put my quotes around this, and now, assuming this is supposed to be a character string, I'm now comparing a string to a string. And when I added the index in the column, it knew it was a string. It knows. It's smarter than I was. That's fine. I run the same exact query with quotes around the number. I can notice that the reads went way down from like 11,000 to 35, and I can verify here I was seeking a lookup. And realistically, this ran sub-second. Stats time tells me it was like 15 milliseconds. This is fast enough. I don't need to add all these extra columns, the invoice ID and the contact person or whatever. I don't have to do that. This index is good enough. It's fast enough, probably, so we're good. So just quick primer on what we're looking for in a query and what kind of things might happen. So how about something funny like this? All right, well, what happens here? I have a query and I run it, and it's really, really, really slow and taking forever and returning a lot of data. I should be suspicious, first of all, the number of rows coming back is this big. I personally know the invoices table and the orders table, and I know it isn't this big. I know it. I expand this and I look down and I see the numbers going off to the astronomical land, and I say, all right, something's wrong. I thought this made sense. I investigate and I realize, oh, the or. I don't want an or, I want an and. Whoops. I made a little logical mistake here. If the or is needed and it's still slow, you might want to split it into two queries. One on this and one on this. But in this specific case, this is a typo. This should be an and. So I'm going to fix it. This should be a join on two different columns together as a compound join, and I run it and I get my results back fast. It's still a lot of data. I'm scanning the tables, I get it. But it didn't return infinity rows or some very large number, and it didn't run for as long as it took me to wait patiently, about 15 seconds. So, cool. What are other things we can do to break our execution plans? Well, we can have a leading wildcard. If I want to search, whenever you put a percent at the end of something, it can use an index, because indexes start from the left and go to the right. It's a leading index. But if I put a percent in front of something, well, I have no idea where in the string I'm searching. And this is not like Elasticsearch or some cool tool like that, or full text indexing or whatever. SQL Server is going to have to search the whole thing. So if I run this query right here, I get my results back, but I will note that I scanned the table, the whole thing. And the reason is because I can't tell which full names are like this without searching them all. I just can't. I have to go through every single character, every single string, and check them all. So I can go back and ask, do I really need this leading percent? What if we just do a leading search instead of a wildcard leading search? Like, can I do this instead? And if the application allows this, great. Make the change, call it a day. Now it's faster. I get a seek, and it will always run faster. If the table gets bigger, this will be more efficient. If it's not allowed, if I have to have a fuzzy search, then you need a different tool potentially. You can do hash tables and n-grams, and there's all kinds of trickery in SQL to do text searching efficiently, but you might need a better tool. That's all. Text searching is not what a transactional database is good at, and full text indexing is available in SQL Server. It might be an okay solution. It's not the perfect one though, but it might be good enough. Just consider other solutions that are available to you before you give up and let it be slow, or give up, period. You should never be giving up. Similarly, avoid putting functions on columns. This is a common thing people do logically as developers. We say, hey, this makes sense. I want to cast the column. I want to convert it. I want to date add it. I'll just throw that right in the column and be done. But when I do this, SQL Server now needs to analyze this, this whole expression first before doing the comparison. And because of that, it's got to read the whole thing. So again, I get a scan and a lookup. Now I did scan a non-clustered index, which is a little better than scanning the clustered index, but it's still a scan. I went through every row in the table to get this. That's unfortunate. I didn't really want that. All right, can we improve it? And the answer would be just move this over here. Do I have to have that on full name? Full name is already at 50. Do I have to cast it? Like, actually notice that I cast the full name from nvarchar50 to varchar50. Did I even need to do that? Could I move whatever the functions are over to the scalar? Or could I adjust the statement somehow to keep this nice and clean? Once it's nice and clean, I run the query, and it comes back better. Index seek, key lookup, better. Don't have to always have it that way, but it's nice. And do I even need to cast at all? Like, could I just go ahead and do this? Is this good enough? Might be. Again, this is a question to ask people that use this software, developers, the people that are working with this data. the end users, whatever. Find out the right people to talk to and check, is any of this really needed? Like, do we functionally want to have fuzzy searches, or functionally want to alter the data before checking it? Does it even make sense? So, loads of questions to ask, loads and loads of questions that come out of how we use our data. So a lot of that has to do with inefficient joins and filters. The goal of a filter on any query at all is reduce data size and do it fast. That's all. However many rows are in your table, a filter should reduce the number of rows so you have less data to return and the data is relevant. You know, if I'm a user and I want to see orders in an ordering system, or tickets in a ticketing system, or customers in a customer storage, CRM system, I want only my data or the data I'm searching for. I don't want everyone's, right? If a table has 1 million orders and I have 5, I just want to see my 5. And in fact, the people that build the software only want me to see 5 too. They don't want me seeing everyone else's. That's a security problem. Just my 5. So the point of the filter would be get that query down from 1 million to 5 as fast as possible. That's the point of a filter. So whenever you filter or join, those predicates should reduce the size of data down to what you need to satisfy the query. And if they're not, that's a problem. So kind of as the demo showed, keep all those columns clean. That's very important. Avoid all the case, or, cast, convert, fuzzy, functions, whatever, weird stuff on there, because that's going to make things complicated. Now when I'm trying to filter, I'm doing a bunch of stuff at the same time that may not be easily solvable by the optimizer. It may make things slow. So keep your columns as clean as possible. If you have scalar variables, throw as much as you want on them. Evaluating a scalar is fast, but evaluating a bunch of stuff in a column is going to be slow. Or just move it elsewhere. Maybe that conversion should be somewhere else, maybe earlier in the stored proc, or earlier in the code, or maybe the column should store the data differently as a varchar 50 instead of an nvarchar. Whatever the change is necessary, consider making that change. These are architectural considerations that go, well beyond just optimization and tuning, but what is the right thing to do with your data? So keep filters as clean and straightforward as possible. If your query returns too much data, more than you need, find a way to improve the filters. Again, if I want 5 of something and I get back 1 million of something, even if the application filters it later, the database is still sending 1 million of something over to an app, and the app is then throwing away most of it. That's inefficient. And so recognize when that happens. It's very, very useful. We already did all this. I'm going to move on. Here's something. And again, if you have questions, feel free to throw them in the chat. If you're asleep, well, you're not going to hear me. But hopefully you're all awake and enjoying this a little bit. But if you have questions, feel free to toss them in. I will take a look at them and happily answer them. This is a common problem that we don't always notice because queries don't have to always perform terribly. Like, we think a bad query is one that takes 10 minutes to run when you want it to take 5 seconds to run. But the reality is that it may not always be like that. Sometimes a bad query is a query that runs too much. And this is something you may not notice as quickly. But a spammy query is one that simply runs a lot. Like, the same query runs over and over 1,000 times a minute. But does it need to? To do the same query over and over, it's worth asking somebody, is this a normal part of the app where people really are going to do this over and over? And if so, great. That's fine. Architect around that. Have the indexes, have all the structures to support it, and life is good. But if not, ask that question. The number of times in my career I've seen queries that check for user user preferences, or environment variables, or things that almost never change, licensing counts, whatever. Like, the number of times I've seen queries that check for stuff that never changes, or that changes less than once a day, and checks it non-stop every single time you run a query, or 1,000 times an hour, or 1 million times an hour. That number is a big number. And if you go back to developers and ask them, hey, can we just cache the result of that query and save it until the underlying data changes and then clear the cache? They're probably going to say yes, because it'll be more efficient. So always look out for spammy queries, and don't be afraid to ask about them. Why is this running 1 million times a minute? And the answer may be this is expected and normal, and it fits the workflow of the application and how it functions. And if so, cool. Some apps really do have queries that run that much, and that's great. But if that's not normal, if someone says, well, that's strange, we only do this 1 time an hour, or the user shouldn't do it that often, especially if it's a user. If a query is coming 1 million times from a user every hour, There's no user clicking on something a million times. Obviously something's wrong and the same thing's running over and over. Who knows what's happening? Ask those questions. Don't tolerate spam. You know, the same query being spammed over and over for no good reason is a problem. We should solve that problem. So be aware of these, though, because a spammy query may not be as slow as the one bad query. It may just be something that takes 50 milliseconds or 100 milliseconds or half a second. But if it runs enough times, it doesn't matter, right? One query that takes 5 seconds is not that different from a query that takes half a second but runs 10 times. It's at that point exchanging, one thing for another. So just consider this as well, because it's a very common problem and it's a little easier to miss. All right. This is something that in code, application code, makes loads of sense, but in the database does not make so much sense. Iteration is the sort of thing that SQL's not built for. Database like this is meant to be set-based, and queries more often than not should be set-based. And you shouldn't be selecting rows one at a time or 5 at a time normally. Typically, if you're in a transactional application, you should be grabbing your data, inserting it, updating it, and deleting it in chunks. If it's analytic data, you may want to update it in even larger chunks. Running 100 rows in one single query will perform way better than 1 row at a time in 100 separate queries. This is a balance, of course. Obviously blocking and performance are different things. If I select 1,000,000 rows out of a table that I need, and I block everybody else in that table potentially, if I select 1,000 at a time or update 1,000 at a time, it won't happen. But keep in mind that the iteration in general is something that's going to make things slow unless you're doing it intentionally. On the flip side of that, of the spammy query and the iteration doing the same things over and over and over, the alternative is going to be a really, really complex query. And we've seen these before, right? I'm sure we've all seen the query that's like 2,000 lines long, or that has 50 tables and things like that. We'll all run into. If you haven't run into that, great. You're lucky. Go you. If you have, though, you'll feel my pain here. The more complex the query gets, the harder it is for the optimizer to evaluate all the combinations of tables, joins, operators, transformations to get what it needs. As a result, the more complex query is, the more likely it is for a bad plan to be given. And even if the plan is correct, it may be a plan that has to involve a ton of tables and functions and views and whatever else to get what it has to get, and that might be slow. So in general, if your query is giant and it's really slow and you can't really find a single place in the query to fix and make it fast, you're not missing any obvious indexes and things like that, if there's no obvious solution, well, maybe the solution is break a big problem into smaller problems. If you're joining this into this into this, maybe you should take the 3 thises and separate into 3 queries and then get the results and join them together at the end. That might be more conducive to a fast query. So think about taking a big problem and subdividing it into smaller problems that you then can have better solutions to. It's really important. You will run into the big bad query. I've seen procs that are tens of thousands of lines long, triggers tens of thousands of lines long. They exist out there in the real world and they're scary, but we can break them into smaller problems, simplify them, make our life better. This is pretty easy to demo and show too. First off, iteration versus set-based, very, very easy to demo. If I were to put an update into a loop and update rows 1 at a time, 100 times, well, the execution plans are going to certainly take a while. I'm going to stop, turn off the execution plan, do it again, run it. It takes a while, and I note that every single iteration is 2 reads over and 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 over. So 100 queries, 2 reads to 200 reads. And that's a lot of reads for a relatively small table. On the flip side, if I simply say, do the whole thing at once, it runs faster, and it does less reads, but Kio is much faster. Instead of running through a loop and doing the same thing over and over, it did it in milliseconds. On the complexity side of things, what do we do about complex stuff? And this is really common. I make up a query like, I'm even going to run this thing. I don't really want to. I make up a giant query, table, join table, join table, join table, etc., 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 etc. The first thing I'm going to ask is, what can I do to simplify this query? Whether it performs perfectly, not so great, or horribly, my immediate question is, do we really need all this at once? Let's say it's performing badly. One of the first things I'm going to think about, if I don't see an obvious problem, is can I divide this into smaller problems? Maybe can I divide out the product data into one query and filter it, and then the rest of the joins later. And then to do that, I would simply say, all right, get my product data that I need, and only the columns that I need, by the way, not all of them, and drop it into a temp table. And then run a big query now against the original stuff that I need plus the temp table. This may very well make things much faster. I took that data that was being joined in this giant thing, and I split it up into smaller problems. There's many ways to do this. This is not the only way to do it, but think of ways to simplify a problem into smaller steps. This may or may not be the relevant way to do it for your problem, but it's one way to do it. So whenever a problem's too big, the query is too big, the function's too big, the proc is too big, consider dividing it up into smaller functions, smaller procs, smaller queries. Maybe they're a little more specific. Maybe instead of having one proc that's massive, I'll have 5 that each handle a specific use case. They're all smaller. Think about it. This may be a way to make things faster without the torture of having a giant query you're forced to tweak. Because the bigger this gets, the harder it is to optimize, the harder it is to tweak. Good question about temp tables. This is just an example of how to do it. A temp table with a single £sign is only available in the local session, which is generally going to be what you want. If the data is needed more permanently somewhere, like you're going to use it for many reports over the course of a day perhaps, then to go with Angel's question here about what do we do with the temp table, maybe put it into a more permanent table. I generally shy away from global temp tables. A global temp table has 2 signs. Those are available everywhere on a server, but they also have no security associated with them, and there's some danger there of breaching security protocols, making data available everywhere. So if you want data available for a longer period of time, maybe consider a more permanent table to put the stuff in. Maybe it's in its own schema or domain or something like that. But good question. If I want to share a temp table later in an effort like this, what would I do? And the answer would probably be, if you don't want to use a global temp table, which is kind of insecure, use a temporary permanent table. In other words, a permanent table that is going to get cleared out, truncated, dropped later, but that's okay. Good question. This is another fun thing. This happens a lot, especially by developers with a little less database experience, but even then, it's an easy mistake to make, and I don't fault people for doing it the first time or the second time or even the 10th time. It's very easy, like in code, where we can nest methods, nest objects, and encapsulate. It's really easy to think of databases the same way. I can nest a view inside of a view, and that view calls a function, and then a proc has a bunch of those, and a trigger has more of those, and so on and so forth. In general, encapsulation in of itself is not bad, but when too many objects get nested inside of each other, a view that calls a view that calls a view, not only do we have this nightmarish door scenario like the picture shows here, but it's really hard to understand, hard to follow, to document, to use, and there's a chance you may do things more than you want to. You may read the same tables too many times, you may read tables you don't need. A lot of the times it's a sign that you're putting too much business logic in the database. Instead of business logic being in an app, where it probably belongs, you're now putting all the logic of an entire app in the database. And it might seem like the right thing to do, but overall it decreases performance over time, and it's very hard to document in a database what's going on and understand how something works. Whereas in an app, apps are built for this. App code is built for this, Java, C#, whatever is built for this. Databases are not, and it gets very confusing. What you end up with are objects, calling objects, calling objects, calling objects, calling objects, you get the idea. And that's really, really rough. Do I have a demo of that here? I do, and this is great. So let's say I want to get some customer data back. I might go ahead and just run this query here and get back the results. Let me run the execution plan too. And it comes back quick enough, but I note that when I do it, I get a lot of columns back. I did select star, and I note that I had a lot of tables accessed and a lot of reads. And the execution plan is kind of complicated. This is like a 4-line query, and the execution plan is quite chunky. Well, why is that? And the answer is that this is a view. It's a view. If I go and expand it, there's the view definition. Oh, there's a bunch of columns in here. I didn't see all that, and it returns a bunch of stuff, and I'm hitting a bunch of tables. Oh. So is the view something I really want to use? Do I really need all those columns and joins, or do I not need all of them? And the answer is, if I don't need them, just go to the table and get it. So instead of website.customers, the view, go to sales.customers, and just get what I need from the table. And again, I select star here. You'd reduce this down to the columns you need only and stop there. And I can see very clearly that less tables, less reads, even if I'm selecting star, less reads, less tables. The execution plan is not quite as crazy. It is a little crazy because there is, I believe, some spatial stuff going on this table, some temporal table stuff. But again, it's simpler than before, and that's what I want. So consider ways to simplify queries and not make them too complicated. It's very important, very common problem, easy mistake to make, but when you get into the habit of doing this, it gets very hard to unmake these mistakes and break the habit. And this can go down a very bad path where you have 10 levels of views that call each other, and it's really hard to know what's going on and understand why it's slow. And it can take even somebody with a lot of expertise and experience a lot of time to understand truly why it's slow. Symptoms, of course, of this problem are you're seeing tables get hit that you don't need, too much I/O against tables, you're seeing a whole table get read when you only really need a little bit. Might be, or way more overall I/O than you ever expect for a simple query, right? You ran a 3-line query, the thing's torturing you. Why? Maybe you run a simple query and the latency is high, and you're asking, why is it so slow? Maybe your results return stuff you don't expect. There's some extra rows in there, some extra columns in there. So your data was formatted a bit by the view in a way you didn't expect. It got rounded maybe, or converted, casted, whatever. Maybe you didn't want that or expect that. Maybe your row counts are higher or lower than expected because there's filters in there or no filters in there. So these are all symptoms you can look out for to know that something's happening to your data, and maybe you don't want that to happen to your data. We did that already. That's great. So kind of one of the last things I'll hit on here before I begin to wrap up, as we begin to get close to an hour, is parameterization. There's whole sessions. I have entire sessions on parameterization and plan reuse and parameter sniffing. An important thing about parameterization is that execution plan reuse is a very good thing. This is the best practice, it's the norm, it's what you want. You want plans to get reused over and over and over. You want queries to put a plan in cache and reuse it over and over and over, because making execution plans is expensive. You don't want SQL doing it over and over. Recompiles are usually not a good thing, especially on queries that run all the time. So we want reuse. Reuse is good. Parameter sniffing is an outlier. It's an exception. It can happen. It'll probably happen to everyone eventually if you do this enough, but it's an outlier. It's the sort of thing that happens once in a while, and it's very often a sign of code problems, not necessarily SQL problems, but it could be. You shouldn't architect around parameters. Your whole app shouldn't be built around preventing parameter sniffing. When parameter sniffing happens, you should treat it like an outlier and don't try to cheat it, please. It's something that you want plan reuse, and that's important. And a lot of the hacks we put into place to deal with that will cause trouble. I put a link in here too. You can check it out later in my parameter sniffing presentation. I'll send it all out afterwards. Feel free to look at it and enjoy and chuckle at some of the fun things that I put in there. I've seen it all in production before. I promise, everything you see there, I've seen in production. It's a joy. It's awesome. I will also say the internet handles parameterization and parameter sniffing very badly. If you ask ChatGPT, solve this for me, you might get a very bad answer as the very confident first answer. So I do beware that this is a complex problem, not a simple one, and the internet's not very good at solving it. A lot of the things people do, dynamic SQL hacks, local variables, hard coding literals, whatever, all that stuff will maybe make something go faster short term, but it may cause other problems in the long term. Or you may simply make poor cardinality estimates that helped you right now, but then hurt you for the rest of your life. So avoid hacks and just don't do them unless there's a really good reason to do so, because when you start hacking around the problem and hacking around parameter sniffing and putting it everywhere, you're going to cause trouble. Trouble? Well, this is the eventual thing that happens. So I have a problem in production. I fixed it with some trickery. I'm proud of myself. And then I say, you know what? This worked once. Let's put this everywhere. Let's wrap all of our stored proxies in dynamic SQL, and that'll fix dynamic parameter sniffing. Oh, these queries are slow. Let me put no lock on them and get rid of all the blocking. Yay! The plan is giving me trouble. Let me force plans, which is legitimate, but it adds a lot of documentation. I start throwing around trace flags and query hints and other kinds of random changes. I spam indexes all over the place and the problems go away. I throw dynamic SQL around in ways it was never meant to be used, and the strange tweaks too. Like sometimes we'll tweak, play, tweak, play, and then suddenly it works. Oh, I changed the in to an exist and it works. Well, clearly in is better than exist, or exist is better than in. That may or may not really be true. Those are, to the optimizer, they can be very similar, and there's nuance there. And to say that one is better than the other is dangerous, especially if you go spamming that everywhere. And so when you have an emergency and things are busted and you want to fix it, by all means, do whatever it takes to get production working. I get it. Production is important. Your app is important. Make it work. But once you've fixed it and it's working, now you have to go back and get the underlying cause and resolve it. You can't leave the hacks in place, and you shouldn't copy the hacks everywhere because you think they're awesome. Because now you're taking the outliers and the problems and turning them into the way everything gets taken care of, which is dangerous. So be cautious. Undo the hacks, and don't reproduce hacks everywhere, because this is like a huge pit that we fall into. It's easy to fall into, and it's easy to be confident that we're doing the right thing, when in reality we're burying ourselves in the future and creating tech debt. So we're about an hour in. I do want the chance to ask questions if needed. Efficient data access is key to anything you do in an app. If your app can't get to its data fast, people are going to wait. When people wait, they're unhappy. When people wait, the servers are probably performing poorly. Servers performing poorly means things cost more money, whether you're on premises or in the cloud. Your SQL servers will cost more money to run, more I/O, more network bandwidth, more memory usage, more CPU, whatever. And so poor performance means it costs more, and people are mad and frustrated and waiting for things. And this isn't simple. The solutions won't always be easy because you have people involved. You have business logic, which is notoriously complicated. People can make mistakes. You can see tech debt out there, old code that got carried forward for years and years and years. And of course, assumptions. People make assumptions. I know how this works. I can do what I want, and I'm wrong. I see a comment here about people throwing MaxStop in, changing it potentially, and that might be the right thing to do, but it may not be. Typically, your server MaxStop should make sense and give you the parallelism you want in general. Not too many for your cores, not too few. But if you're tuning queries with MaxStop and it's too high or low, or you're just hacking it everywhere, yeah, that can have a huge impact. You're definitely right there. I see the comment coming through about MaxStop. You can use AI to help, definitely. Everyone's always asking, can AI help me? And the answer is it can help. It can give you ideas, potential solutions, but it's up to you as the developer, as the administrator, as the engineer, as the whatever, to prove the solution out. Extraordinary claims require extraordinary evidence. Prove it out, show that it works, and then you can go ahead. And if ChatGPT gives you the right answer, if Copilot gives you a key piece of help, awesome. That's wonderful. You're using tech to your advantage. But if you got to prove it, though. You can't just use whatever it says. You got to make sure it's correct. And if it's not, if you can't prove it, find another solution. This is a valuable skill that will not only lead to things running faster and better, but people will write better software. As you optimize queries, as you improve performance, that's going to go back to development teams. It's going to go back to database people. It's going to go back to QA. It's going to go back to everybody. They're going to learn how to write better code. You're going to have better data architecture. All these things will help you in the future. And so optimization is more than just tweaking a query and making it fast. It's learning how to write better code so you can get to your data as fast and efficiently as possible, which does a whole host of valuable things for us, reducing cost, improving performance, making things go faster in an app. People love when things go faster. So you'll make better software as a result, and you'll be happier in the future. So that's my wrap up there. My next question to you is, do you have any questions or comments or anything you want to throw out there before we begin to wrap up at the end? The floor is yours. If you have any questions.
I think you answered all the questions. Great
Thank
presentation, absolutely. Thank you so much.
Thank you. I'm going to post the slides and the demos.
Yes.
Thank you. So, quick note, I'm going to post all the presentation, the slides. Feel free to find me on LinkedIn or wherever. I post about free training and articles and things all the time and data. Feel free to look me up. I will post this on the meetup. I will hand it over to the organizers. Therefore, you'll have the queries, you'll have the demos, you'll have the presentation. So yes, I will send it all over. Feel free to use whatever you want here, and if you have any more questions, reach out, ask. I'd be happy to answer. There's always exceptions. There's always funny stuff in the world of data. Do feel free to ask questions if you have any.
And if you do not already know, we are recording this session, so we will be posting it sooner than later. And if you are not following the YouTube channel, we have cloud. If you click on Cloud Data Driven on YouTube, you'll find our YouTube channel, and yeah, you can see the upcoming recordings over there if you missed. So yeah, people are asking about your contact information, Edward.
Yep, it's here. I will post it. I can swipe out of here my LinkedIn. That would probably be the easiest thing to swipe out right now. I'm not gonna throw my email in the chat right now. That's probably a bad idea, right? But we can edit the link, and you can find me. You can start by finding me here, and then from there we'll go from there. So I'm just chucking that into the chat. But it is in the presentation as well. So when this gets sent out, you can click on these links. They'll take you to my MVP profile, my Sessionized profile. You can find a mountain of presentations I've done before for Cloud Data Driven, for other groups, other conferences. If you go to an event, you might see me there. So that's all great. Feel free to look up future events as well. There are a lot of upcoming events out there, like Past Summit on Tour, Past Summit in Seattle. There are many SQL Saturday events. Lots of free training and user groups. Always look for free training when possible, or cheap training. Lots of great opportunities. And there's a link in the chat that will provide a link to the recording when we're all done. And past recordings too, if you're interested. There's a lot of optimization topics that have gone through in the past, maybe more advanced, maybe more basic, depending on what you're looking for.
Yep. If anybody don't have any more questions, I think we can wrap up for today. And yeah. Thank you so much, Edward, one more time, and I'm sorry for all the issues that I saw today.
Everything went fine. It all went great. It went fine. We had fun.
I feel so guilty. Yep.
Thank you once more for having me.
Thank you for speaking for us, Edward. And okay, everyone, have a great day and have a great weekend. And we will share the recording as soon as possible, so that you can re-watch the entire session again.
All right. Thanks, everyone, and I will hopefully see you out there soon. Have a great day.
Awesome. You too, Edward. Bye.
Take care.
Bye, everyone.
Bye.